Now we're looking at page 8. A couple more definitions and properties we're going to be looking at with this diagram. So the first thing I want to do is move this in a more convenient location so we can see what's going on while we're answering the questions. So let's move on down there and start answering the questions. It says, what does that square mean? Well, literally, it means a square corner. And so it's a right angle at that spot, 90-degree corner. And that means that the line AB and the line CD, this one here and this one here, are meeting at a 90-degree corner. So they are perpendicular, okay? And that word perpendicular is basically kind of like the cousin to parallel. Perpendicular lines meet at a 90-degree corner. And the shortcut statement is to say that line AB, and our symbol is an upside down T, is perpendicular to line CD. Now let's look at triangle EFG. What kind of triangle is it? Well, it's got that right corner. Okay, so it must be a right triangle. Easy enough. And it is also considered to be scalene. All three sides are different. Now, we really don't know that for sure yet, but we will when we start looking at some of the angle measures. All right, so next part of this is asking you to put in the measures EGF, which we see right here, EGF, and BEH as 65 degrees. Since the measure of EGF and the measure of BEH, that's what that little M stands for, are equal, then line segment GF and ray, taking a look at that arrow, EH, are parallel. How come? Well, here's where we're using that idea of corresponding angles in reverse. So you see the letter F formed from that vertical, almost vertical line AB and the pair of lines, line segment GF and EH, ray EH, they form angles that are equal. And so these are called, as I said, corresponding angles. Because they are angles formed by the transversal AB and they're on the same side of the parallel lines. So we've seen this before. Now we're just seeing it in reverse. So knowing that those two angles are 65 degrees gave us the fact that these two lines must be parallel because of corresponding angles. Next, we're looking at the measure of angle BEF, which is basically another 90 degrees because of the perpendicular lines. Remember, all four of those angles, like four corners at an intersection, are going to be 90-degree angles all the time. So now the measure of angle GFE, and again that letter M stands for the measure of angle GFE. Now we're talking about an angle in a triangle, and you could look at it as all three angles total up to 180, but seeing as one of them is 90, these two remaining angles must also total up to 90. So 90 minus 65 is going to be equal to 25 degrees, thanks to the sum of the angles in a triangle is 180 degrees. And you can use abbreviations. The angles in a triangle equals 180 degrees. We have those abbreviations in math to make our lives easier. 25 degrees. So the measure of angle FEH, let's look where that is, FEH. Well, we know it's 90 degrees there in that corner, so that's going to be equal to 25 degrees. Thanks to complementary angles. Or another reason that that would have to be 65 degrees, 25 degrees, is that we have that Z property going on. We have the alternate angles that are going between those pair of parallel lines, the Z, And so same deal, you could have used that. And BEH we know is 65 degrees. Thanks to, again, complementary angles, you got corresponding angles. Um, anyways, let's say the corresponding angles first, which we already spoke about. And the last deal is the complementary. Now, the reason that it's important to recognize these two words sound a lot the same, they both start with CO, and we get them mixed up every once in a while, not to mention the spelling. So you want to make sure you're aware complementary angles add up to 90 degrees total, okay, not percent. And corresponding angles are going to be equal to each other, um, equal pairs formed from that F, okay, for parallel lines. Hopefully this will help you. Have a great day.